All right, now let's talk about some properties that come up with radii and chords. Now, radii is just the plural form of radius, so it means when you're talking about more than one radius. And a chord, remember, is any line segment that goes from one point to another point on the circle. It has 2 points on the edge of the circle. So here's our property. It says that in a circle, if a radius is perpendicular to a chord, so here is a radius. Remember, radius is a line that goes from the center to the edge of the circle. If we have a chord that's perpendicular to that, okay, and notice they have it marked as perpendicular. If that happens, then it bisects the chord. Bisect, and it bisects the arc. Okay, so remember, bisect means to cut into 2 equal parts. So this would be cut into 2 equal parts, and the arc on the outside would also be cut into 2 equal parts. So to draw it separate from that, what they're saying is if I had a circle like this, and I have my line tool, I have a radius, and not only do I have a radius, but I have a chord that happens to be perpendicular to that radius. Okay, there's my chord, and let's say that they form a right angle. Then I know that this bisects, the radius bisects the chord, cuts it in half, and it cuts this arc in half. So if this part of the arc is 30 degrees, this part of the arc would also be 30 degrees. If this line segment is length 1, this line segment would also be length 1. Okay, so that's the theorem, and that's what happens. The other property is that in a circle, the perpendicular bisector of a chord is a radius or a diameter. This just goes the other direction. It says if you happen to have a line that cuts a chord in half when you're in a circle, that line that cuts it in half, and is perpendicular to it, that's what perpendicular bisector means. It's right angle with it, and it cuts it into 2 equal parts. If that happens, then you know that that line is either a radius or a diameter, because those are the only ones that can do that. This is just the theorem written in opposite ways. Okay, this one starts saying you have a radius, it's perpendicular to a chord, and if that happens, it cuts it in half. And this one says if you have some line that's cutting a chord in half and it's perpendicular to it, then that line must be a radius or diameter. Okay, the important part is being able to apply this information. So let's do an example where we apply it. This wants us to find the length of chord QR. Okay, so QR is a chord. Again, they want us to find the length of that chord. We need to find the length of this line. So far, all they've given us is the length of this line here and this line here. They did tell us that these are perpendicular to one another. And we can see that this black line coming out is a radius because it comes from the center to the edge of a circle. Well, the property told us that if we have a line that goes from the center to the edge, a radius that's perpendicular to a chord, then it cuts that chord in half. It bisects it. So we know that this has been cut perfectly in half. However, we need to find one of our halves. Right now, we just know this is length 8. So here is how you work a problem like this one. What you do is you draw another radius, because the radius is the same length no matter where you go to on the circle. The center to the edge is always the same. So you pick the place you want to put it, and we're going to draw it from the center to one of our endpoints so that we can use the Pythagorean Theorem to solve this problem. Now notice what that does for us is it creates a right triangle here. A right triangle where this side is length 8, and this side, any guesses on what it is? This is a radius, so it should be the same as the length of this radius here was 8 and 8 more. 8 plus 8 is 16. Okay, notice that would have been 16 there when we put it together. The radius over here should be the same length. So now I have a right triangle. I know the leg and the hypotenuse, and I want really badly to know the length of that leg. So what I'm going to do now is just kind of pull that right triangle out here, just kind of pop it out of the figure so that I can work with it, and then we'll go back once we find our missing part and finish up our problem. So again, I have this right triangle. We determined this side was length 8, this side was the hypotenuse, it was length 16. We know anytime there's a right triangle and you have 2 of the 3 sides, you can use the Pythagorean theorem to solve it. Hopefully you remember the Pythagorean theorem says that a squared plus b squared equals c squared, where a and b are the legs of your triangle. Those are the sides touching the right angle. So this would be my a, would be 8. The b would be the side I don't know. I'm just going to call it b for now. And the c is always the hypotenuse, that longest side that's always across from the right angle, right across from it. So my c in this case is 16. Hopefully we remember using the Pythagorean theorem. Let's solve this. So first we square, and remember squared means a number times itself, not the number times 2. So 8 times 8 is 64. B squared we can't really do anything about right now. And 16 squared is 256. We want to solve for b. So we're going to go ahead and subtract that positive 64 from both sides of the equation so that we can get the b all by itself. Now we have b squared equals 192. Okay. We're not done yet because the b still has a squared on it. So we have to think, what's the opposite of squaring? Because that's how we solve equations. We do the opposite. The opposite of squaring something is doing the square root of that number. So we have the square root of 192, and when I find that, I will have my b, and I'll be partway done with this problem. So I use my calculator. The square root of 192 is 13.9 if I round. Okay, so what do I know? I know that this side of the triangle is 13.9. Where did it come from? It came from right here. So this line has a length of 13.9. Now remember, this was bisected, so this part also has a length of 13.9. They wanted the length of QR from Q all the way across to R, and now I can find that. I know the length of chord QR is 13.9 plus another 13.9, or 13.9 times 2. Okay, we get 27.8. Okay, so let's take a look back again at our process. We noticed that we had a radius that was perpendicular to a chord, so we knew it cut that chord into 2 equal parts. We then drew another radius so that we could form a right triangle. You want to draw it specifically from the center to the end of your chord. I knew the length of the radius because they told me that the 2 parts were 8 and 8 for that radius, which would be 16. So whether we draw it here or anywhere else on the circle, the radius will always stay the same. So I knew it was still 16 over here. I popped that out so I could look just at the right triangle. I knew this was length 8 and this was length 16 from what we'd done, and I used the Pythagorean theorem to find that last side. Once I knew that side was length 13.9, I noticed they didn't just want that portion, they wanted the entire chord. I knew it was cut in half, so this part was 13.9. That made this also 13.9, and I put them together to get the full segment.